0.47. 245.126. Okay. So we can calculate the maximum stress for Kevlar, right? So the n, the coefficient is, you have to include it, is 95 over 53, right? And then multiply by 10800. Still the same. The y is still the same. The second moment of area did not change. Right. So this is equal to 95 over 53 times 10800 times 3.475 divided 153.105. So this is equal to 439 minus 439.376 psi. Okay. So we have to pick both from the top because the distance from the centroid is the furthest. That's why both are at the top and both will be under compression. So from here, this is the end of our series for bending moment. Okay, so this is the end of series for bending moment. So the next one that we are going to go for, okay, is shearing stress. Okay, so I like to highlight shearing stress is one of the most complex topic in structure analysis. But I've made rules for you to apply that will make it easy. Okay. Okay. So why is difficult? Okay, is because these rules have to be satisfied for your analysis to be successful. And this topic only has two formulas. Okay, I know you guys say, how come two formulas is so difficult? So we are looking at shearing stress or shearing stress. So this is chapter 6 in your textbook. Okay, so shearing stress. Go on. So shearing stress stresses acting parallel to the surface. So if we have an element, okay, an element is a square, or is the region of interest that you want to analyze. Okay, so if you look at an element, okay, a 2D element, I go the 2D element. Right, and this is our transformation. This is x, and this is y, right? So as the term says, the shearing stress are stress acting parallel, okay, not perpendicular, parallel. So this is our shearing stress. Okay, and the other element. So those of you that have done 303 with me, you know what I'm drawing. Okay. So if you look at this element over here, or let's do it. So this is our plane intersecting the x-axis, right? So if I draw this plane on the transformation, this is the plane, right? So the plane is intersecting the what? X-axis. You better use a different color. All right, this is the plane intersecting the x-axis. Okay, and then the other one, this is the plane intersecting the y-axis. Okay, so this is y-axis, right, intersecting the y-axis. Okay, so if you look at this arrow that I'm highlighting in yellow now, this is the shear. Okay, the intersecting plane is x, and the shear stress is in the y direction. Okay, so this is this term over here, and this represents the direction of the shear force or shear stress vector. Okay, and the other side is shear, right? Y, because the intersecting plane is a y, and the arrow is in the x direction. So this is the x direction. Okay, and they have to maintain the state of equilibrium such that the shear in the xy direction has to be equal to the shear in the yx direction. Okay, so it has to comply to the state of equilibrium. So if we quickly look at a 3D element, okay, so I'm going to draw a 3D element now. So 3D element, still this is my x, my y, right? So this is our y, and then this is our z. Okay, so I'm going to construct a 3D element. Yeah. All right. So in 3D element, there will be 6 different shear stress description, right? So I'm going to write to you. So you have this one over here, right? So the intersecting plane, so this is shear. The intersecting plane is x, and the direction is y, right? And then you have one over here, right? So for this case, shear, the intersecting plane intersect the y-axis, and the shear arrow in the x. Then you have one more set acting this way, right? So the plane is acting on intersect the axis at x, but the direction of the shear stress is in the z. Okay, so you have the other way. So shear, the intersecting plane is in the z, the direction of the arrow is in the x. And then the last one, right? So the shear, the intersecting plane is the z and is going up in the y direction. The shear stress vector over here, the intersecting plane is in the y, and the shear force vector is in the z. Okay, and again, it has to comply. Okay, it has to comply to this set of rules where shear xy. Okay, is equal to shear yx. Okay. Shear xz is equal to shear zx. Shear yz is equal to shear zy. Okay. Now, what I propose is we go for a 15 minutes break. We come back at 8:45. Okay, we come back at 8:45.